All right, so I meant to say at the end of the last video that you should now be able to do 2.6 day one homework. Um, this is posted in the Haiku site, but the homework will be the front and back, and it just mimics the types of problems that we covered in class. And I'll post solutions at the very end of the day that it's actually due. So this day one practice will be due on Wednesday. So I'll post solutions on Wednesday for that. And then day two, we then will take notes. So again, day two is on Wednesday. Basically, what this is a little more complicated problems related to literal equations. So let's go ahead and go over these day two notes. Again, go ahead and just pause the video because I'm going to go directly into how to solve these two warm-up problems. But you should especially be able to do problem A because this is just a two-step equation. There's only one variable and we're being asked to solve for what exactly that variable is. And then onto the right, it's something a little similar, but now we have two variables. This is now a literal equation. We're solving for y, and so we're trying to get y by itself, and then everything, including that x variable, must be on the right-hand side. So go ahead and pause and try this on your own, but I'm going to, again, go into the solution right now. So looking at problem A, solve for y. Again, this is just a two-step equation. The first thing I need to do is, so I got my two sides of my equation. I'm focused on the left-hand side because that's where my y variable is, and I need to get that y variable by itself. The first thing I need to do is get rid of the constant on this side. So this 3, I need to subtract away because it's positive. I'm just doing inverse operations. If I subtract 3 on the left, I have to subtract 3 on the right. So on the left-hand side, 3 minus 3 just goes away. It's 0. And I'm left with a positive 2y on the left-hand side. And that's all equal to, on the right-hand side, I have 15, but then I also had to take away 3 to balance my equation. Well, 15 minus 3 is 12. I'm not done because y is not by itself yet. I have 2y equal to 12, so I have to undo this 2 in front of my y. Well, this 2, because it's directly in front of my y with no plus minus in between, it's assumed to be multiplication. So 2 times y equals 12. Well, to undo that multiplication, I have to do the inverse of multiplication. So I have to divide by what exactly that number is, that coefficient in front of y, which is 2. The reason why that's super helpful is because 2 on top of my fraction, 2 on the bottom, aka 2 divided by 2, is just 1. Essentially, they cancel each other out, and I'm left with just 1y on that side. And that's all equal to, well, on the right-hand side, I had a 12, and I had to divide both sides by 2, so this side is divided by 2 as well. And 12 divided by 2 simplifies to be an exact whole number, which is 6. And I've reached my solution. Y is equal to 6. Again, we could check to make sure that's right. Like if I plug this back into my equation, so 3 plus 2 times what I said y is, which is 6, and I get 15, it better equal 15. So this does, the solution does check out. Now on the right-hand side, this is a little more complicated because we just learned literal equations. So in this problem, we're being asked to solve for y, but again, there's another variable, this 4x. So in this problem, the first thing I need to do is, first of all, I have my two sides of my equation. And I'm kind of focused again on the left-hand side because that's where this y is. And I need to get rid of everything around that y. I need to get rid of this term, the 4x, and then I'm going to eventually need to get rid of this coefficient of negative 12 in front of my y. Now, this one's a little more complicated than we looked at yesterday because it's a multi-step problem. Technically, it's just 2 steps. In problems like this, the first thing you want to always do is to get rid of any terms that are being added or subtracted to like your y grouping. So we have this term here, this negative 12y. We're gonna save that to like the end. All of your y's, we're just gonna keep on carrying down all the way into the last step. What we wanna get rid of first is any term next to it. Well, this is just a separate term, this 4x. So in order to get rid of those 4x's on that side, we have to do the opposite of that. Well, this 4x is technically being added on this side because there's an invisible positive symbol in front. So in order to undo, or in order to get rid of a positive 4x, we have to do the opposite, which is subtract. We're going to subtract off 4x on this side just to get rid of it. Well, if I subtract off 4x on the left-hand side, I have to do the exact same thing on the right-hand side. And notice, when I write that, I kind of wrote it kind of far to the right off of this 24 because these are not like terms. I don't like line them up together. We're not going to be able to combine these. They're not like terms. So the reason why this is beneficial and the reason why it helps us out is because we just got rid of this 4x on this side. A positive 4x, I have 4 x's, and then I take away 4 x's. I have no x's left on this side. I've essentially canceled those x's out. What I do have left over on this side is a negative 12y. So I'm going to bring that down. A minus 12y. Got my equal sign. And then on this side, again, I cannot combine these. They're not like terms. So I just have, I'm not going to be too picky about the order in which you write this, but technically your variable should go first and then your constants. So on this side, I have a negative 4x. And then next I have my constants, which are just a positive 24. Again, the symbol in front of this 24, there is nothing in front of it, so it's assumed to be positive. I'm not done because I haven't solved for y. I now have this coefficient in front of y that I need to get rid of, this negative 12. Well, again, this negative 12, invisible symbol in between, it's multiplying my y. So how do I undo multiplication? I divide. That's the inverse operation. So I have to divide by this coefficient of negative 12. And if I divide by negative 12 on the left-hand side, I have to divide every single term on the right-hand side by this negative 12. So I'm going to divide this first term by a negative 12. I'm going to divide this second term by a negative 12. So I divided every single term, both terms on the right-hand side by that negative 12. So on the left-hand side, a number divided by itself. That's essentially what I have. A negative 12 divided by a negative 12 is just 1. So I'm left with just y on that side. Perfect. That's what I was trying to do. On the right-hand side, though, for this first term, I have a negative 4 on top, and I have a negative 12 on the bottom. When you stick that in your calculator, you're going to get an ugly decimal. So we need to I'm going to do a little side work here. But I have a negative divided by a negative. That's just a positive. And then I have 4 on top, 12 on the bottom. Well, both of those numbers are divisible by 4. So if I divide out a 4 on top and a 4 on the bottom, I can simplify this fraction. 4 divided by 4 is just 1. 12 divided by 4 is 3. And don't forget that I have my x as well. I can check to make sure that fraction is the same, like 1 over 3. I better get the same decimal, and I do. So negative 4 divided by negative 12 is the same thing as 1/3. See how they have the same decimal value. Now I have a positive 24 divided by a negative 12. So a positive 24 divided by a negative 12. Oh, that's a whole number. It's just a negative 2. So a negative, or subtract away, 2. And that gives me my final answer then. Y is equal to 1/3 x minus 2. So down below, that was just the warm-up. Down below is where we would actually go into like all the notes. So this first set of notes is just a reminder of how literal equations work. The first thing there says identify that variable that you are trying to isolate. That's what goes there. There's basically always a variable like, oh, solve for w, solve for k. Up above in our warm-up problem, we were solving for y. So the first step is always to identify the variable that you're trying to get alone. The word I'm using is isolate, which just means to get alone. Which variable are you trying to solve for? That's always the first step. Got to look for that. How do you do that? Well, you use, same as before with one-step, two-step, and multi-step equations, we're using inverse operations. in order to get that variable by itself. So we're using inverse operations to move terms away from the variable that you're trying to isolate. I'm sorry I didn't include much room for this, but I gave just a little bit of advice down below and in the notes. Basically, when we're using inverse operations, what you're essentially doing is you're doing PEMDAS backwards. A lot of times you're using addition and subtraction first, and then you're using multiplication and division last. And then there's not going to be too much with as far as exponents or parentheses with literal equations, so we don't have to worry too much about that. But the first step is usually addition and subtraction, and then the last step is to multiply or divide. Just a little bit of advice with fractions. In order to get rid of fractions in your problem, we will always be using reciprocals. And then just a little last hint is that the last step, and I just kind of talked about this, the last step will be to usually divide, sometimes multiply, by whatever is next to your variable. But again, it's usually division. So let's look at some sample problems down below, starting with number 1. So we're being asked to solve for W in this complicated formula. P equals 2L plus 2W. Again, we're trying to get this W by itself. So we're going to have to eventually get rid of this 2 and then this 2L, this other term off to the left. So we have our two sides of our equation. Again, we're going to essentially be using backwards PEMDAS. The first thing that we're going to do is either add or subtract. Essentially, we're adding and subtracting the other term that is with the variable we're trying to get alone. So we're trying to get this W, but this 2 belongs to the W. Essentially, this is like one term right here. And then we have our other term, 2L. So our goal is to get 2L, get rid of that other term first. And how do we do that? Well, this 2L, again, the symbol in front is positive. So I'm going to do the opposite of that, which is minus. I'm going to minus all of this, 2 L's on this side. Well, what I do on the right-hand side of my equation, I have to do on the left-hand side of my equation. So I'm going to subtract away 2L on this side as well. Notice I didn't line it up with the P because they're not the same variable. I cannot combine them. They're not like terms. So when I simplify, on the left-hand side, I have my variable P, and then I'm taking away 2L. So that's what I have on the left-hand side. I have my equal sign in the middle. And then on the right-hand side, I used to have 2L, but I took them both away. So essentially, they cancel each other out. 2L minus 2L is nothing. And what I'm left with is this positive 2W. So on this side, I have 2W. And I'm not done, though, because I have not gotten W by itself. I need to somehow now get rid of this 2 in front of W. Well, the question becomes well, what is this 2 doing to my W? Well, it's multiplying my W. So to undo that multiplication, I have to do the inverse operation, which is divide. Again, the last step is usually division, not always. So I'm going to divide both sides by that 2. I'm just going to go ahead and divide everything on this side by 2 instead of doing like each term individually, which is like up here I did each term individually. So technically there is another type of answer I could get here. So I'll try to do it both ways. Let me do it so you can kind of see what I'm talking about. So another way I could have done this problem, like I'd divide this side by 2, and I could divide each of these terms by 2. So either way is fine. I would have to accept either answer. So let's look at this first method first. 2 divided by 2 is just 1, so I'm left with just W on the right-hand side. On the left-hand side, though, there's nothing I can really do to simplify. I have my P minus 2L on top, and that's all divided by 2. So that's my final answer. I would also accept this. So if you divided each term on the left-hand side individually by 2, that's also legitimate. I still have 2 divided by 2 on the right-hand side, which cancels each other out, and I'm left with just W. On the left-hand side, P divided by 2, there's nothing I can cancel there. I have my minus sign in between. And then I can cancel something here. 2 on top, 2 in the bottom, kind of similarly. They cancel each other out, and I'm left with just L there. So I would accept either of these answers because they're both technically correct. Looking at number 2. Number 2, again, if I have a fraction on the right-hand side, again, you guys have been really good with ratios and proportions. Let's make the left-hand side a fraction as well, aka a ratio. So this s, just throw it over 1. I now have a ratio or a fraction on the left-hand side and a ratio/fraction on the right-hand side. So I can use now cross multiplication in order to solve this problem. But keep in mind, I'm trying to get k by itself. So I'm eventually trying to get this k all by itself on one side of my equation. So let's look at the cross products. The first cross products I have. 1 times k minus 10f. Well, 1 times all this stuff is just whatever this stuff is. So it's k minus 10f. And that's all equal to my other cross products, s times p. So I have s times p. Again, I'm trying to solve for k. K is now on the left-hand side of my equation, and what's along with k that I need to get rid of? Well, this minus 10f stuff. So I need to get rid of that minus 10f. Well, how do I do that? I use inverse operations. This 10f is being subtracted away, so I need to do the inverse of that. I need to add exactly what this term is, 10f, to the left-hand side. If I add 10f to the left-hand side, I also have to add 10f to the right-hand side. And notice that I kind of segregated it off to the very far left. I did not write it underneath s and p because s and p and 10f, they're not like terms. They're not the same variable, so they cannot be combined. So when I do that, on the left-hand side, a negative 10f and then I add 10f, they cancel each other out. They're just 0. And I'm left with just k on the left-hand side. I got my equal sign in the middle, and I'm going to bring down exactly as everything appears. I cannot combine them. They're not like terms. So I have sp, and then I'm adding to that 10f. Hey, look, I solved for k. I got k all by itself on the left-hand side. This is my final solution now. K is equal to all this stuff, whatever s times p is, plus whatever 10 times f is. Moving on to the backhand side. Again, we have a word problem here. I'm not going to read through it. The two important things that I have to note are the formula that I'm given. So this formula right here. And then I'm trying to determine the height. So I'm trying to solve for the variable h. But if I were to read this, it says Ben and Jerry are planning to make the world's best ice cream cone. They know the volume and radius of the cone, but want to know what the height of the cone should be. Use the formula v equals 1/3 times pi times r squared times h to determine the height h of the world's best cone. So I have this. Volume equals 1/3 times pi times r squared times h. I just want to emphasize that all of these items are being multiplied together. Essentially, this is one giant term. One giant term. Remember, terms are separated either by an addition, subtraction, or an equal sign. The reason that this is one giant term is because it's just separated by multiplication, which again doesn't separate terms. So this is just one giant term on the right-hand side. Now, in order to be successful in this problem, it goes back to one of my hints. To remove fractions, use something called reciprocals. Notice that I'm not going to be doing like ratios and proportions on this problem. It's because there's only one fraction on the side. Like the whole side here is not fractions. If this entire side was fractions, I would highly encourage using ratios and proportions. But there's only one part of this term that is a fraction. If you have just like one part of your term that's a fraction, get rid of that fraction by using reciprocals. So we're going to multiply the left-hand side by the reciprocal of 1/3, which is just 3/1. Essentially, we're just multiplying by 3. 3/1 is just 3. So on the left-hand side, I'm multiplying by that exact same number, 3, or 3 over 1. Notice I didn't write this side as a fraction because v is not in terms of a fraction, so I just wrote it as 3 times. So on the left-hand side, I have 3 times v. In the middle, I have my equal sign. Now, on the right-hand side, when you multiply a fraction by its reciprocal, everything goes away. Everything meaning just the fraction. So I have 3 on top, 3 on the bottom. Essentially, 3 divided by 3. They cancel each other out. Same thing with the 1 on the top and the 1 on the bottom. They essentially cancel each other out. And so both of those fractions disappear, but I still have all this stuff left. So I have that pi times r squared times my h. Again, I'm trying to get h by itself. So now I'm trying to get h by itself, but I have all of this stuff in front of h, or multiplying h. Well, if this is just, all this is just a number. I don't know what the number is because I don't know what r is. But essentially I have a number multiplying my h. Well, to undo a multiplication by that number, I just have to divide by exactly what that number is. In this case, I have to divide by pi r squared. And if I do that on the right-hand side, I have to do it on the left-hand side. So dividing by pi r squared. Now, on the left-hand side, there's nothing I can do to simplify. It's just 3v on the top, pi r squared on the bottom. Got my equal sign in the middle. But on the right-hand side, I have a pi on top, pi on the bottom. Essentially, pi divided by pi is 1, cancels itself out. Same thing with this r squared. I have r squared on top, r squared on the bottom. Well, r squared divided by r squared is just 1. They cancel each other out. And what I'm left with is just h. And that's exactly what I was trying to solve for. Height is equal to all of this stuff on the left-hand side. 3 times your volume divided by pi r squared. I want you to try the problems at the bottom. So it says you do. I'm going to go ahead and go into the solutions immediately. So go ahead and pause the video, but try these on your own to see if you're capable of doing this. But for number 4, go ahead and pause. Number 4, it says solve for y. Got my left-hand side and my right-hand side. I'm trying to get y by itself. So the first thing I want to do is get rid of this term next to it, this 2x. And again, the symbol in front of that 2x, because there's not one, it's assumed to be a positive. So I have to do the opposite to get rid of it. I have to subtract away 2x. What I do to my left-hand side of my equation, I have to do to my right-hand side of my equation. And notice that I wrote, again, this minus 2x pretty far over because I'm not going to be able to combine it with this negative 6. So I don't write it directly underneath there because I can't combine them. So on the left-hand side, I have 2x and I just took away those 2x's. There's nothing left. There's no x's left. They cancel each other out. But what I'm left with is a negative y. So I have negative y, essentially a negative 1y. Got my equal sign in the middle. And then on the right-hand side, I have my minus 2x. And then I also have a minus 6. So I bring that down as well. Y is not by itself yet. There's a coefficient in front of it of a negative 1. So I have to get rid of that next. Well, that negative 1 is just multiplying my y. So to undo that, I'm going to divide by negative 1. I do the inverse of that multiplication. I divided by negative 1. Well, if I do that on the left-hand side, I also have to do it on the right-hand side. There's, again, more than one way to do this. I could just divide everything by negative 1, or I could divide each term on the right-hand side by negative 1. I'm dividing each term by the negative 1, by the way. So on the left-hand side, I have a negative 1 on top, negative 1 on the bottom. Essentially, a number divided by itself is just 1. Negative 1 divided by negative 1 is just 1. So I'm left with just y on that side. Got my equal sign in the middle. And then on the right-hand side, essentially when you divide by a negative 1, all it's really going to do is it's going to change the signs on the right-hand side. So a negative 2 divided by a negative 1, negative divided by a negative is a positive. And then 2 divided by 1 is just 2. So it's just 2x. Notice all it did was change the sign from a negative 2x to be a positive 2x. Same thing here. This used to be a -6. Well, now it's just going to change the sign to be the opposite of +6. Again, looking at that, a negative divided by a negative is a positive, and 6 divided by 1 is just 6. So I get my final answer. I've solved for y. I have y on one side, and then I moved everything else to the right-hand side. So y is equal to 2x plus 6. Now let's take a look at this last problem. It says solve for c. So I have a equals 1/2 c plus 25. On the right-hand side, kind of focus on the right-hand side because that's where my variable c is, but I have this term here, 1/2 c, and then I have this term here, this plus 25. Again, when you have more than one term, try to get rid of the other term besides c first. So I need to get rid of this positive 25 first. Well, to undo a positive 25, I have to take away 25. I have to do the inverse operation. And what I do to one side, my right-hand side of my equation, I have to do to the left-hand side. So I'm also going to take away 25 on this side. Notice I didn't write it right underneath a because a and 25, they're not like terms. A is a variable, and -25 or -25, it's a constant. Don't confuse it with, we're not combining it with the number of our problem. So let's go ahead and simplify. On the left-hand side, I have my a, my variable a, and then I have my -25. Again, cannot combine them. They're not like terms. So I just bring it down as it is. On the right-hand side, though, I still have this 1/2 c. So 1/2 c. And then this positive 25, I took away 25, so it actually went away. 25 minus 25 is just 0, so that's gone. So now I'm left with this equation. C is still not by itself. I now need to get rid of this 1/2. Well, how do I get rid of fractions? I multiply again by the reciprocal. Well, the reciprocal of 1/2 is 2 over 1. So I'm going to multiply this side by the reciprocal of 1/2, which is 2 over 1. Essentially what I'm multiplying by, 2 over 1 is just essentially 2. I'm multiplying by 2. Well, I have to do the exact same thing on the other side, the left-hand side, but be very careful. I'm multiplying everything on the left-hand side by 2. So all of this stuff, a minus 25, is being multiplied by 2. That's why I throw it in parentheses to emphasize that this 2 is being distributed or multiplying both of those terms. So on the left-hand side, I have 2 multiplying my a and multiplying this minus 25. That's why it's in parentheses. And that's all equal to, on the right-hand side, again, I multiply by 2 over 1. So I have 2 on the top, 2 on the bottom. They essentially cancel each other out. 2 divided by 2 is just 1. Same thing with this 1 on top, 1 on the bottom. They cancel each other out. So those fractions, again, when you multiply a fraction by its reciprocal, the fractions just go away. And what I'm left with is just this little old variable c. And I have my final answer. You could also show this distribution. If you leave your solution like this, I will accept it. Or you could have written it, so showing this distribution, you could have expressed your answer as 2 times a, and then 2 times a -25 is a -50, all equal to c. I would have also accepted this. So either is fine. Either not doing the distribution or actually showing the distribution. So with that said, after this lesson, I'm giving everybody 2.6 day 2 homework or practice, and I'm asking them to do both sides. So 1 through 6 on the front, and then there's some word problems and additional problems on the back. So a total of 10 problems. So this is Wednesday night's homework. Check it on Thursday. And then on Thursday, again, we are moving into a review session for the test. And then Friday will be the actual test. I'm guessing that a lot of Thursday will be still kind of talking about, especially in extension, talking about literal equations, because I expect for this to be really difficult for people to understand. So I highly encourage you to ask questions, not only in extension, but also come to my second period ASP to get help, because these are tough. Thanks, Emily. I hope your trip is going well, and I will see you soon. All right, bye.